So, hello everyone. Good afternoon, good evening. Thanks for coming to this session, and special welcome to Patrick for his session. He will introduce us to Buildpacks, right, Patrick?
Exactly, yes. So I think Buildpacks is a very powerful tool, which you will learn that the way you probably did containers before is just like wrong on so many levels.
Okay, so let's just jump into the topic. So the stage is yours, Patrick. Let's start.
Thank you very much, Silla. Understanding Buildpacks, delving deep into their functionality. So the goal of the session is to understand like what Buildpacks are, how to use them, and then I also will show you some examples from the field, like how you can use it for your project, what it or why it would make sense like to use them in your company, maybe also some typical issues you might face with Buildpacks. So that's actually like the goal. And everything is about containerization. So, me like start the first slide. I'm Patrick. I'm from Switzerland. I usually do like some technical coaching for agile teams. So that means like I help people or software teams to deliver better quality faster, which is very important these days, and even in the age of AI. But we are not going to touch the AI topic today. I'm sure there are so many other sessions on that. I usually focus on development of software solutions with humans. I like the interaction with people, and I think if you use frameworks like Spring, technologies like Java, containers, and so on, it's just a tool. And besides that, doing coaching, architecture, development reviews, and training, I lecture also at the University of Applied Sciences in Zurich. And I have students where I teach the things I know, basically like from the field in the university. I'm part of the Swiss Java user group, where I serve as a host in Zurich location and St. Gallen location. I'm a Java champion, I'm an Oracle ace, and also I'm the co-organizer of Vox Days Zurich, which is a small one-day conference in Switzerland. And you will find me over the internet with Pat Baumgartner as my nickname. So what are we going to look at? So we are going to see like what containers really are. Probably that's just a recap for most of you. Then actually like we start talking about Cloud Native Buildpacks. We talk about comparing Buildpacks to Docker files. So why you should use Buildpacks over Docker files. Then we talk about like some Buildpack CLI, because there is tooling around. Also probably on the example of the CA certificate integration. Then we shortly have a look at like software supply chain with some tools which are just like built in to create, for example, SBOMs, but also like you could add very easily things like agent to add observability in your application. We'll have a look at some advanced Buildpack features, then also on customizing your Buildpacks. And of course, we will tackle also like the big elephant in the room, or the big tool or the big ecosystem, which is basically like Paketo Buildpacks. And of course, we'll also like shortly talk about like how you should integrate your Buildpacks into your CI/CD pipelines, because I believe they don't belong on the developer's notebook. You should not run them there. They should always like run just like in the pipeline, because like, yeah, locally we run applications. So that's actually like the goal or the agenda of tonight. And we are just like starting with the first topic. Of course, we know what containers are, and we have been using them for many years, probably like almost like a decade or so. And we learned that like we have the need for isolating applications quite a bit, which gives us a lot of flexibility. So you could deploy applications with different platforms, like different versions of those platforms, and different libraries and whatever, you name it. But the thing is like having an isolated process, having an isolation of the application helps a lot. And therefore, actually, like Linux tools are used, like chroot, namespaces, and cgroup to create like this kind of like isolated thingy we run in a very lightweight way. Of course, you will have access through a part of, let's say, like an abstraction to the kernel, right? So you could actually like read files and other resources, network and stuff like that. The goal in general is basically like that we have something which is like easy to deploy, easy to start fast, right? And also something which we just can run in different places, just like move it around. And of course, when we talk about containers, we usually talk about container runtimes like Docker or Containerd, which are like different implementations for this kind of technology. On the right side, you just like see like the different layers we get in this part, where we basically like have at the bottom the kernel from the OS. Then we have like the base image on top, which basically like inherits the kernel. And then we have different layers where we add like different things. As you can see, for example, like the JVM, like the jars, some metadata, and even, for example, the entry point definition, like how you run your jar. So just like layering here. And of course, if you are going to like create containers, they are made up of layers, and we just need to ship the new layers which were changed, right? Because like everything else can be basically like cached. So what are then Cloud Native Buildpacks? So Buildpacks is basically a CNCF standard. And Buildpacks, there is something called Buildpacks.io. It's a nice website which defines the standard. There is also like a GitHub repository behind, and we'll see that like in a few minutes, what they deliver besides just like the specification. Buildpacks.io is a good starting point if you think of like writing your own Buildpacks. Yes. So where do the Buildpacks origin from? So you can imagine like in the early days, let's say like 2010, 12-ish, there was a platform very much used in the cloud, like as a platform as a service, which was called Heroku. And they had something because like at Heroku, you just configured the repository, they created the container for you, and they were running your application. So that was basically like the version 1 of Buildpacks. And Buildpacks is actually like without any Docker files, just because like of some definitions which were read, and then the container is kind of created. And we are here not talking about like Docker container, maybe in the first version, because there is, or there has been in the past, many different ways of like creating containers. Yeah, like LXC containers and others. Then later, in time, a bit later, there was something called like Cloud Foundry. You probably remember. Cloud Foundry was also like a cloud platform. You could just do like CF push, deploy your war file, your fat jar file there, and then the platform created for you the container to run the application. At the same time, also Heroku was basically like doing another version of their Buildpacks, and you see that like with version 2 and in the flavor of A and B. And then a bit later, both got together and basically defined the standard for Cloud Native Buildpacks, which is now part of this CNCF project, which is actually defining the standards for Buildpacks. So that means like many other vendors or tool creators can actually like use this standard for container creation, right? We'll get into that also like in a minute. So that's actually like the idea. So we get OCI compliant images. So OCI is basically like this Buildpack stuff, or like the standardized containers basically. And usually like the way the tooling creates is it's just like doing some checks on for example some files which are provided, and it will guess what kind of application you want to containerize. Good. So if you think of now Buildpacks, and you know that there must be some tool out there which now creates like magically containers, then actually like you could think of like different vendors which implement like Buildpacks. And of course, you could say, for example, Heroku has their own Buildpacks, Google has their own Buildpacks, and there is something called Paketo. Paketo Buildpacks is another implementation. And from my experience, like writing Java applications or even like Java applications, Go applications, maybe sometimes a little bit of Python applications, and if I want to containerize them, you have probably the biggest and up-to-date ecosystem in this Paketo umbrella. So Paketo is basically an implementation of the standard. And imagine if you're using, for example, Spring Boot or so, you would use like Paketo Buildpacks under the hood of Spring Boot as well. So Paketo is actually a thing which is used for different technologies to create containers. And you just like see on the image that there are different categories. Like you might have like a Java application you want to containerize, GraalVM native images, for example, Go. You have maybe some .NET things, or maybe some static files or JavaScript application, Python, PHP, Ruby, you name it, right? And basically Paketo provides you the tools to create like for all these kind of like technologies, the way how you can create containers. So actually, if you think of like why are Cloud Native Buildpacks relevant today, you could actually say it's very important that we are simplifying the way how container images are created. And that means like we do not want to write Docker files. Probably you would see like in your company that there are different standards of writing container files or Docker files, right? And that makes it hard to like fix issues, vulnerabilities, or maybe like other things. And you really want to have like a standardized way, even across different teams, for example, and environments, which just makes it like easier for everyone. Then actually like the other thing regarding security is if there is like a community out there, you could actually like leverage things from like tooling, like base images and so on. And that's actually really awesome, right? So in the Paketo ecosystem, you're not alone. So there is a huge community which is actually like maintaining the tools and the base images and so on. And they do their best actually. Another thing is you can actually like integrate, for example, Paketo or Cloud Native Buildpacks in general very easily into your CI/CD pipeline. And you can also like create reproducible builds, which is even more important these days. So I will not go into that topic so deep, but you can imagine if you're building it multiple times from the same source, you will get like the same container. And also caching is really like important there because you don't have to download everything all the time from the network. Right. And therefore, because of like the ability to run it from the command line and so on, it really fits like very smoothly into the modern DevOps workflow. So Buildpacks produce OCI containers, OCI compatible images, right? So we can actually run it. But there is a huge ecosystem around. So you see on the drawing that there is like PaaS platforms who need to support that. So you could think of like container runtime from Google. You could think of like Cloud Foundry from any kind of like Kubernetes environment where you can deploy containers and so on. We have like CI/CD tools which support that just like with plugins or like other tools very easily. And then also like on your local machine, you also have like frameworks like, for example, Quarkus, Spring Boot, or others, which actually also help you with this. We'll dive into that a little bit deeper later. And the other thing is even container registry have picked up. Before you could see like on container registries only like the layers as they were defined inside the Docker file. But these days you can also like see easily like what's the layer or like what's in the layer produced by Buildpacks. So this is just like some company names I know, and with some I have been working with these tools, just that you get an idea for different tools and platforms and container registries which are out there, which are just like supporting this kind of technology. And as you can see, it's quite everywhere. So from source code to production-ready container image, standardized and Docker file free. That's Buildpacks, right? Buildpacks automate and also unify the application delivery. So it really makes it simpler and standardized. Now, let's have a look back at what is actually like this Buildpacks thingy. So if you look at the standard on GitHub, there is like a few things which are quite important here. You will see like the 6 pinned repositories, and you will actually realize there is actually like a specification on the upper right. There is a lifecycle on the second line on the left side, which is defining like what happens when. So the lifecycle library is very important. It's provided by Buildpacks.io, right? And that's also something, for example, like frameworks like the Spring Boot, Maven, or Gradle plugin is actually like using behind the scenes. And then, of course, there is this pack CLI. Pack CLI is the thing you can actually like execute on the command line. And then actually like you could use builders and build packs from Paketo, from Heroku, from Google, and so on. So I think actually like the three repositories, pack, lifecycle, and spec, they are the most important ones. And everything is quite well documented. Now the question is like, why should I use Buildpacks instead of Docker files? And there is a famous example. If you look at this one, it looks kind of obvious what you would do like with your FetchJar application when you would run it. But there are so many flaws in here. One issue is basically, if we talk about like where we inherit from, what's our base image, that's the OpenJDK base image. There is no tag, there is no definition there. It might be even outdated, right? That might be an issue. Another issue, of course, is that we are running the FetchJar. For example, if you think of like a Spring Boot application, we know already for quite a while that like an exploded Spring Boot application, which is basically like unzipped, like starts faster than if you would run the FetchJar. And the FetchJar also like is a problem because like the layer for the copy line is quite huge, which needs always to be replaced. So if we would explode it and it would create multiple layers, we just could like change the files which really change, or change the layers where the files have changed. So that's definitely like also an issue. Another issue, depending on where you run it, might be also like your privileges. So typically, if you don't run on a special environment, here the application would start with the root user. And you don't want that. You don't want to have a privileged user here. You want to run it with an unprivileged user, which allows me or like prevents that maybe like something bad could happen. Yes. So there is many issues actually like with writing your Docker files, and you really need to know like what to do. And therefore, I think it's way better to actually like use a tool like Paketo or Buildpacks in general to like simplify the way we create containers. If you're interested, I linked in the description below something called the 10 best practices to containerize Node.js web application with Docker. It's a blog post from Snick I like a lot because they show exactly like what you can do wrong when writing your own Docker files. So just Google it. I'm pretty sure it will open your ideas like what could go wrong. So let's now talk about the Buildpacks CLI, because like that's like the first tool out there. And we'll have a look at the demo later. If you have this command called pack builder suggest, it's actually like suggesting you what kind of builders are out there. You can imagine a builder is something like a summary of like all the tooling, and you can basically like select the builder which defines, for example, like a base image and the tools in there. So if you do this like pack suggest, and for this one, I just jump into my CLI to show you. I have like executed already the command, so we don't have to wait here. You just need to believe me, that's like the output from half an hour ago. It will tell me actually like what kind of builders are known to pack. But of course, it's not limited to those. There are many more out there, and you can actually like use them as well. What I find interesting is that, for example, you have like builders for example, Google. You have builders for Heroku. You have the Paketo Buildpacks builders for different things. For example, like for Ubuntu Jammy, in different flavors even. And then it actually also like if you need to use like UB8 or UB9 from Red Hat, there are even builders for them too. So you can actually like really select what kind of like base image you want and the tooling and so on. And we can also shortly have a look at this one. I'm just like going to execute it here, and we just like use one of those, and you will actually like see. Let's hope it's running. Typo. Okay. So it should actually like print out what kind of like tooling is behind. And what you could actually like see here is that there is, for example, for Java native images, stuff in there. One build pack for like doing these things. So every line here is a build pack, right? Then we have like Java. We have also like Go here, as you can see. And that's just like behind. So all of these lines here, all these kind of tools, that's just like a build pack which can do something, right? And then actually like a builder groups things together which belong together. So you don't have like to reference everything on your own. It's kind of like a collection of tools. Let me jump back to my presentation now, and we'll get back to the demo thing a little bit later. So you could run now your build packs with the Paketo build, and you could say like with -- builder, I want to choose that builder to run my application, right? To like execute the things. And we'll see later what it actually means and what happens behind the scenes. As well, also like if you want to change to Paketo Buildpacks below, you also see that you can easily change, for example, Ubuntu Jammy, Ubuntu Noble, for example, whatever is there basically. Now, the question, if you, for example, like run a Spring Boot application, might occur, what is this part up here? You probably have seen that if you start your Spring Boot application from your IDE, or like the one you run, probably if you have created a Docker file, you won't see these kind of things here. And just as an example here, in my pet clinic, where I created a container with Buildpacks, they will do some things like, as we can see here, like calculating, for example, like how the heap should be sized, for example. They are also adding quite a bit of parameters here, as you can see, like things like, for example, exit on out of memory error, which means like if the application has not enough memory anymore, it just tries to restart immediately. And well, not restart, basically like the application crashes and then Kubernetes will restart the application, right? There is other things which are added. For example, it's called Spring Cloud Bindings, which is like live and readiness probes, for example, and also like memory tracking, for example, here, and a few other things I will talk to you a bit later. Another thing we see basically like when we start, that's my current Java version, and it started by a user called Cloud Native Buildpacks, so CNB, and it's not the root user. You would actually see if you do that, without Buildpacks, it would be written there root, right? So that's actually also like a great thing. And what it also does is Buildpacks, as I said before, deploying a Spring Boot application would be nice to have it in an exploded way. It will do that for you behind the scenes. You don't even like realize that there are different layers created in an exploded way. Okay, so now let's ask the question. If you're in an enterprise environment, you would have to add probably like self-signed certificates. It's a very common thing to do because you have self-signed certificates, right? You need to add them to every single container so that you can basically like validate those certificates. So you add basically your CA to it. Now, instead of doing it like for all the Docker files in the right way, there is the possibilities basically to just like provide some bindings to the container when using Buildpacks. So what you can see here is on top, I created kind of a structure which looks like this, and then basically like just mounting a volume to the container while building the app with the back CLI, and then actually like the CA certificate gets automatically added. We don't have to care about like using key tool for Java and other tools like for other environments, you know, it's just like done behind the scenes. So it's like for all the different platforms, it's the same. We also would see like that there is one added because typically it's 146. And I'm pretty sure if I jump just back here, we would see probably here, yes. So standard would be 146. And if I add my one to it, then it's 147, which are added to basically like the JVM Trust Store. So imagine now if you're building Go applications, Node.js applications, Python applications, Java applications, you just can do it the same way, adding certificates to your container. And that makes it super simple, right? So Buildpacks really simplify my life. Now, let's go a little bit deeper. So like what's part of the Buildpacks architecture? So you can imagine there is something called a build image. A build image is actually like used to do like the things while the container is created. There's quite a lot of tools in there and it's quite huge because like you need, for example, a Java compiler, you might need like other things. And then in the run image, you might have something like smaller in there because for Java, you might just need like a JRE. So it's different, JDK versus JRE, for example. But there is other libraries which are needed or just provided in the build image. There's just like more in there. Yes, so typically like with Paketo, it's like Ubuntu is like the base OS. And they called that build and run image before like stack, but the term is deprecated and will like go away over time. Buildpacks itself are things which are now changing the container like layer by layer. Every Buildpack is basically a tool to like, for example, add Java to it, maybe unzip, for example, the fetch jar, whatever. You know, there might be Buildpacks, many Buildpacks to do like a job. There is another thing actually like called lifecycle, and we'll see that later, which needs to be orchestrated. And the lifecycle library does that job so that the things get executed in the right order. And then the question might be still like, what's a builder? And the builder is all of the above in one image. So a builder is basically also like just like an OCI compatible container image, which contains build image, run image, Buildpacks, lifecycle, and so on. And there are like some which are bigger because they have more things defined, and there are others which are smaller because there is less in there. But you still can like customize quite a bit. And I will show you some examples a little bit later. Now you can imagine, now you have source code. You execute Buildpacks and the output will be actually like a container image. And in the Buildpacks itself, now in this step where we do like an operation on the container, where we change basically the container for something, we have a phase which is called like detection. And detection is, for example, checking things like, is there like a jar file? If yes, then we need to install Java, for example. That would be like the detection. And the installation part would happen actually like in the build part. So there we would, for example, install the JRE. There is a meta definition for all of this. It's called buildpack toml file. The toml file describes like the meta information. So for example, the name, the version, like the API level we are using, and so on and so forth. Right, great. So here again, like shortly summarized, the detect phase is for checking things. So you could imagine we have Java files or a jar in there, so it's checking for that. And then it might download or install like the JDK or the JRE, or might compile things, or it does like some additional environment variables, or just like sets the Java tool option, parameters, and so on. You could also imagine a thing like it detects a POM file and it would run the build for you, the Maven build, right? That could be also the thing of a build pack. So it's always like detecting and then executing. So we need to know that the build pack is used, so that we know like there is like an order of build packs. We'll see later too. And then there is the thing which needs to be done. Now, the life cycle of build packs actually consists of the analyze, detect, restore, build, and export phase. And you can imagine at the beginning, you need to look at like the metadata. Then we do like the detect. We talked about that already. There might be layers which just can be like reused. And so that's why we have like cache stuff there. And the restore phase will help with that. So that means like there is no need to do a build, for example, if the layer for the Java environment, for example, was already executed like 5 minutes ago. You know, we have downloaded the JDK, we have it locally cached, we just can reuse it. And therefore, there will be a restore phase to do that. In the build phase, if we cannot leverage the cache, it will just build the thing. And the export phase will actually like create the container at the end with all the layers we need, right? So when we are talking about the builder, a builder is basically like a collection of build packs, the run image, and the build image. And it just helps us with all of this. So we can easily just like go like for one, and the magic happens behind the scene. If you want to add other build packs yourself, you can manually do that, of course, by just providing for the pack CLI, for example, some -- parameters, or you can add it, for example, in the Spring Boot Maven or Gradle plugin, also as an argument for the plugin. So in certain environments, you need maybe to customize your build packs. And there are reasons for that. And I've been doing that also in the past because, for example, I don't want to use Ubuntu in my containers. I might want to go like with Alpine because it's more lightweight. Maybe also like because of their C library implementation, which is Muscle and not glibc and other things. And therefore, for example, I just can use like a different builder from a different vendor. And I can create like an Alpine-based container image. Basically, there are some out there, but I could also do that on my own. We have been talking about CA certificates. That's also already customizing. And there is like things, for example, if you're shielded from the internet, that you need to define like repositories, internal repositories or proxies, or maybe you want to have like some other things to be done in there. I will tell you also some examples I've been using in the past. So towards the end of the presentation, there is a very nice actually like thingy which only like Buildpacks has, because imagine your base image has now vulnerabilities. And that would mean you would have to run the pipeline again when the base image got updated, right? And just like the base image layer would have to be changed. Now, actually, like the pack CLI allows us, or Buildpacks allows us in general, just to replace that single base image layer. So basically, or usually it's like the lowest layer, right? And in Dockerfile, it means like you would have to rebuild everything from bottom up. Now, Pack Rebase, for example, allows me just like to fetch the latest run image and just to replace that single layer. And I don't have to rebuild the application on top. So that means like I'm way faster actually like in patching my containers. That's also something which is quite special actually like to Buildpacks compared to other container tooling. If you're interested in Buildpacks, because there are like hundreds or maybe thousands out there, and there is a registry for these Buildpacks, and you will also see like different vendors, and even some of them I haven't been talking about in my presentation so far. Now let's jump to Paketo, because like it's very powerful, and it's quite like big, the ecosystem, you know, there is lots of tools out there. So if you look at Paketo, for example, there are basically like 3 different flavors. Well, you could say like 4, but it's defined like 3 because like the full base image is basically like deprecated. You have like a base image, which is used actually like for major programming languages. Then you have the tiny one, which is like super tiny, which is like the idea to have like native applications. And there is a tiny Java, which just focuses on Java. And there is, for example, also like a static one, which is actually like using static linked libraries inside. Then actually, if you look at the different technologies out there, Java, Node, Python, and so on, we talked about that already. And there is like a lot of tooling out there. CA certificate we have seen, SBOM generation, which is quite neat. We have also like labels for the container, which can be added with the tooling. You probably need in your environment. And then the other thing, which is quite nice these days, is that it also even supports ARM64 images. So that means like you can run it on your Apple Silicon developer notebook. And then, of course, also like if you need to use Red Hat UBI, it's there too. So you can see it's quite broad, the whole thing, and quite powerful. Now, just to show you a little thing, because I think that's quite nice, is the command basically like to extract after the whole container was built, to extract basically like the SBOM file. And you can check actually because it's created with Sift. And you could then also like select, for example, certain areas and to like detect like which kind of library which was used. And in my example of a Spring Boot application, it's, for example, Jackson in there. You see that in the version, you see the SHAs, you see like where it was downloaded from and so on. So basically like all the dependencies you have inside your application, and also like from the package manager, from your base container, everything is actually like in there, which is quite good and quite good to know. And that means like other tools can actually like attach to the container, read the information from, and can also like do some alerting if your application in production now has vulnerabilities in there. So there are like other things which may be quite nice, is, for example, adding additional tooling. Just as an example, for example, when you want to add like a Java agent to your container, with the Buildpack CLI, it's basically just an environment variable you set, for example, here, BP Datadog enabled, and they will add for you automatically the jar file for the Java agent. Of course, at runtime, you need to provide some more environment variables to basically like configure the Java agent so that it knows where to write things to, but also like, for example, with an API key and some maybe other information. Now, if you think of Java, now let's get back to the topic. It's actually also like that Buildpacks are quite great because like by default, it detects from the manifest which Java version needs to be installed. because with the one you have built the application, that's the one which should be installed, of course. You can actually also, while building the whole thing, you can also say like, I want to have a specific one, and you just like specify that with an environment variable. You might even say, for example, in the example below where I say like there is the Adoptium build pack, I want to like install Eclipse Adoptium or Eclipse Temarine basically, and then I want to run like everything else from the Paketo Buildpacks. You'll see that then also like in the demo what it actually does. There is a build pack also, for example, for Spring Boot, which does quite a bit. For example, like it helps like with AOT and AOT caching. It helps like with older versions of Java with like, for example, CDS. It adds like cloud bindings and so on. So Spring Boot has its own build pack, which does quite a bit, which is configurable. But then also because of Java, there is a memory calculator involved. So we can like guess what the heap distribution need to look like. But there is also like build packs for JLink, for example. So we can basically like customize our JVM, but also, for example, there is JMX support if needed. Hopefully not these days anymore in a container environment, but if it would be still possible. And then, of course, we also have seen that already before. There is also the Java native support with GraalVM native. So let's just jump into some examples I have been prepared just to like show you how it looks like. And I just like jump to my application where I just like use like my builder from Google. And you will see like the builder from Google here. I refer to the environment from Google. It will pull some images just to make the output a little bit nicer. I have done that in the past already. So that's why it's already satisfied. So it's not just downloading. And then we see like the different lifecycle phases, like analyzing, detecting, restoring, building, and exporting, as I have said before. So that's part of the lifecycle. And we see like in the analyzing phase where it checks like for metadata that the image, that the container image is not there yet. Then actually like it checks for the build packs, and you see now there are different build packs participating, and there is actually a list of 6, and it says like 5 of them, they match. So we should run them, right? And that's actually like what you see here also, that basically like it's going to run the Java runtime. So it installs basically the JDK. So it downloads the version, it installs it because we have a cache miss. So you see that here. And then it runs basically like a Maven command to build the application, to build the jar file. That happens everything like with the pack CLI. Of course, then it like realizes it's a Spring Boot application, and Spring Boot applications need to be treated in a specific way. And it does that. And then you see like entry point is defined and also labels are added. So that's what's happening here. And as we can see as well, like in the exporting phase, the layers are basically like added. And at the end, the image is created. And I could run it from here. So that's like the example like with the Google one. I've been doing the same actually now with the Paketo Builder Noble Java Tiny on the command line. And here it's different because now we have like 26 participating build packs, and 10 of them are selected, which are also listed here. And you see a little bit more like CA certificates, Bells of Liberica as a Java distribution gets installed, Sift, Maven, executable jar. It checks for Apache Tomcat and Tommy E. Hopefully nothing needed here, right? Since it's like a Spring Boot application. Liberty, we have like a distribution zip, and then actually at the end it runs the Spring Boot one. So it goes like through the 10 of them, and you will actually like realize that they're also listed here, also like with some default parameters, which can be easily overridden as a command line argument. And it's going to download, as you can see here, the JDK, the JRE, right? It creates the layers. It like installs Sift for the SBOM, and then actually like it does the Maven stuff, right? And it even like builds the Maven application here, right? So you don't have to do the Maven things before. But the thing here is just like It does a Maven test skip through. So it's really just like building the jar file for the container. And then you see like the executable jar, the fetch jar thingy. So it reads from the manifest what's the launcher. And then actually like we see some other parameters from the Spring Boot build pack. And at the end, it creates the container. Oops. Yes. So let's go to the next example. The next example is even like I did my own one. And I used a different version of a container. But as you can see here, it's basically like doing the same. So I've been creating my own builder to actually like change the base image with certain things I need in there. Another thing I want to show you, which is quite nice, is like what you could do actually like with Spring Boot. Spring Boot, if you do Maven Spring Boot build image, it will run now Paketo for you or like Buildpacks for you. So that means like if I scroll down here, that's just regular Maven build. That's like tests. And we go in here to the phase where we see the regular output. Now you see here, there is like 7 of 27 participating. So it's reduced. But I even have my own one added because like in Java 25, there is like AOT caching was added. And I had the idea actually like to implement it myself. So so it just like does the thing as we have seen before, but you see now there is no Maven build involved. So the jar was actually like done before because the Maven build is driving the whole thing. So we can just like leverage the thing which was built, right? And the other things are still the same, but it removed Liberty, Tommy E, and Tomcat build packs. So that's why we have a little bit less. Now, interesting for me is like the build pack I wrote is now jumping in and does a training run to create AOT caching, right? Which actually like should help then to like make my application starting faster. And it's actually like doing here a training run, which is very similar to what you probably know from AppCDS. And it just like dumps the file at the end or all the classes loaded into a file. And then actually like we change the way the application is started with an additional argument here to like load faster all the classes which were dumped before in this additional archive. So it's a very specific feature now. And the thing is actually like not only the AOT file has to be created, but also if you would run it, the X parameters would have to be added. And I just like ran the example here. And you see here that, for example, there is an additional parameter added. So the whole formatting here doesn't look so nice because like I just like scripted it in Bash. But if you would now use the regular Java build pack, which is out there now for, I don't know, maybe for 1 or 2 weeks, it would have like AOT caching in there and it looks like way nicer. So now you have heard that you could actually like do that from Maven as well. Let's just jump back to the presentation because I want to show you a few things and challenges and solutions for those. So imagine your customer wants to have a custom font. And if it's a Play project, maybe you want to have an emoji font. The problem is that there is no emoji font actually like in the base image, and you would have to add it. So these days, you can basically like inherit from the Paketo Buildpacks base images, and you just could use it as I did it here with apt-get update and then install, and just like install additional fonts. And I could feed now this kind of like base image or run image into like the Pack CLI or into the Spring Boot Maven or Gradle plugin, right? So that's the way I can customize my own run image. Another thing maybe you want to do, sorry, you want to do different JVM tuning, or like you want to use different JDKs because of reasons, because you need one with a license or so, you can easily customize that, and you can even create your own custom build pack. there are like many other reasons why you might want to create that. As I did in the example with the AOT caching, yeah, sometimes it's just like a thing because it's not like a standard, or maybe it won't be ever added to like the standard build packs. Now let's talk shortly about Spring Boot, because it's quite simple. For example, if you want to add your own builder, you just can add it like this. So in the Spring Boot Maven plugin, for example, it's just a section of a configuration thingy where we say that's my builder, and then we run it from there. You can also use like builders from Bellsoft, which have like Alpaquita, which is a small Alpine Linux thingy behind. Yeah, so you can actually like easily add your own custom builder like in the Maven or Gradient plugin. What I also did as an example here is to show, yes, we could actually also like pull different Java distributions. So if you think of like Adoptium or Alibaba, Dragonwell, or Amazon Corrector, whatever you want to use there, you can do that. And the only thing you have to make sure is that from your builder, you want to select at the end the Java build pack, which runs the additional steps like CA certificate, SIFT, the Spring Boot build pack, and all these kind of things. So this is basically like transitive added in the Java build pack. And we are overriding here just like the one, which by default is the Liberica build pack, right? The Bellsoft Liberica one, with another one we want in our container. Another thing which is quite nice and I like a lot is, for example, I want to use, for example, customized JVMs. So I can actually use JLink and use these additional parameters as an example to like strip down my JVM to have like a very small container just with the Java modules I need. I have added another one, which is called like AOT and AppCDS. So AppCDS was a topic basically like to dump all the class files while you are starting the app in a training run, and then you would like start it again from that archive, and actually like your application would start faster. And if you're still using like an older version of your Spring Boot, not the newest one, then you could use like AppCDS. Now, AppCDS got replaced by AOT caching in Java 25, and that means also like we are in a migration phase with the build packs. So build packs will actually like find out if you're still on 17 or 21, it will use AppCDS. If you are on 25, then it will actually like use AOT caching. And all these kind of things, as you see here, can just be added as an argument. Here I said AOT caching enabled, but don't misunderstand that part here, because Spring AOT is something different than AOT caching. Spring AOT actually like does all the classes which need to be component scanned, and if you have profiles and conditions in there, it will dump the registration of the beans into like Java classes. So no component scanning at runtime. Again, that's Spring AOT. AOT caching is the thing when you start your application and basically like you dump the classes you have loaded into one single archive, so you don't have to search it anymore within the jar files. So that's slightly different, right? And sometimes like for the training run in this example, you need to like adjust the training run because maybe you don't want to connect to a certain server, or you want to have for the training run a different environment. And then it could be like that you need additional parameters for the app when it started, right? Good. Of course, you integrate these build packs into your CI/CD pipeline, because like there you would like create the containers. And of course, also like official maintained containers are usually like security audited and also secured, and they basically also like maintained by the community. So everyone can contribute if you do, and I highly recommend to do so. These folks are super friendly actually, and help you discuss things and so on. So you definitely should contribute. Also, like because of things like SIFT is in there, makes for example security scans easier. Builds are faster if you do them repetitively, because of the caching mechanism from the Buildpacks, for example. So make sure that your pipeline allows the caching mechanism to be used, because then your build actually also will be faster, right? There is also a lot of documentation out there. There is like ways how you can version things properly so that you don't go just like with latest for everything. And Buildpacks are basically like wrapped into containers. So basically like the way you version containers is used here. Yes. And then it's actually like also very easy to integrate with observability, because like Dynatrace, Datadog, New Relic, agents are already out there, right? Which can be easily applied via Buildpacks. Otherwise, it's also very easy to add your own. Great. So I'm getting towards the end. So that's my summary and key takeaways. So you probably have realized now, Buildpacks is just a different approach. And I'm telling you, you should not use Docker files, because Docker files are so complicated, because you need to know so much. And if you don't want to know so much about how containers are created and you want to be on the safe side, then actually like you should use Buildpacks. And I personally like that if certain solutions really like reduce my cognitive load, so I don't have to think about it. I don't have to think about it to do it the right way, because somebody else has done it. Think just like of the example I mentioned before, having fetch jars inside your Docker file and not like use them in an exploded way means like you're really like wasting time during the startup. And if nobody tells you, you wouldn't know. But with Buildpacks, the Spring Boot Buildpack does it the right way for you. Then actually like the thing is, of course, we want to provide value to the end user. So that means like we should not like tinkering around with things. Also, like we have seen that we can use different technologies, but we can also like compose them. So you could, for example, create like a build with an Angular application and a Spring Boot application with Buildpacks. That's quite simple to do that. Then actually, like if you have different applications, you can build them with the same set of Buildpacks. You can reuse them. That's an advantage also across teams, but you should also do that across different technologies. We also only rebuild layers with Buildpacks, the ones which have changed. Everything else will be relinked, which is actually like super nice and provides us faster builds. And then the last one is like the rebasing part, which means like we can change the run image when we need it without actually like building the application from scratch. Great. I'm done with my presentation. If you're interested in the presentation, then actually like I'll provide you the QR code, and you'll find on my Git repo my presentations and even some demos. Also like the ones I did, but also like some additional examples like for builders and Buildpacks and stuff like that.
Thank you so much, Patrick, for the presentation. I think it was a great talk. So thank you so much again. And in the comments, there are some questions that partially they have already been answered. So initially, Vincent asked about the JDK. Buildpack use Liberica JDK. Can I use another one? And I think it was mentioned, he mentioned that it was answered, his question. So you can use another one. And then Francois had another comment, actually a question. I remember around 2 years ago, Paketo Buildpacks used to be pretty heavyweight and had some installed binaries with security vulnerabilities. Do you know if that changed, and do they offer distroless?
So I don't know if there is actually like distroless out there. To be honest, I have not seen anything. I've been, let's call it like nudging the folks from Bellsoft which is behind like Liberica. So they have like this awesome distribution, which is called like Alpaquita for containers or base image, which are like Alpine based images. So they're quite small, just really like a few megabytes, like probably like 30 megabytes or so, maybe even less. And additionally, like with their distribution of Java, they're super small. I like that a lot. And also I've been testing their builders, which are compatible, like with the one from Paketo, like with the default ones. But mentioning also like that, for example, that if there is an Ubuntu, because of like, let's say the package management and so on, vulnerabilities, they also have like reduced the sizes of the run images quite a bit, because we have seen like there is the base, there is a tiny, and there is a full one, and also even the static linked one. So that means like depending on like what kind of technology you're using, you have more tools in there because you need them. And the other thing I have realized is when you have an upstream fix from Ubuntu, it takes maybe like 2-3 days, and it will show up then in the base images also like in Paketo. So that's quite nice. So that means like vulnerability gets fixed like very, very fast. And basically, if I touch, for example, my examples, or if I run workshops, or like even like at work, I have the feeling like every 2 to 5 days, there is an update of the base images. And that means like we are quite up to date with this. You just have to be aware of, for example, if you're using Spring Boot, they're like pinning, for example, a builder for a while. And that means like they really point to a specific version of the Paketo builder, for example. And what I sometimes do, if I recognize something, I use the latest builder, because you can define your builder, add the latest label at the end, and then you can just like use all the new features, and you don't have to wait till the end of the month until Spring Boot provides a security fix. So that's like how I do that, or maybe also like testing new functionality. And especially now the feature, for example, like with AOT caching was super nice, because I was discussing like on issues with the folks, it was like testing for them certain things and so on, that AOT caching like made it now into like the Spring Boot Buildpacks, because I think it's a very nice feature from Java 25. It's very similar to do it like AppCDS was done in the past. So I was just not a Go developer to like write the code for it. So Anthony did that, which like kudos to him, did really like a great job, and also made it in a way that you will automatically migrate, basically like if you upgrade your Java version to 25 from AppCDS to AOT caching. And that means like the community is vibrant. There is a lot going on. You can also like join their Slack channel, for example. There are things discussed how it should be done. Of course, like resources are like everywhere limited, but they really discuss like if it's needed or not. And of course, if there are vulnerabilities, I mean, they do their best to actually like fix it. But my point would be like for Francois, really like use the latest label, then you get the latest builder. That means also the latest like run image, very, very fast. And Spring Boot is just like pinning it to a certain version, which will be updated like every month anyway. So you will get a race of the pinning. Yeah.
Mm-hmm. Very nice. I still have, maybe I can show 2 more comments that I don't see any other questions. But for example, Vincent said, this talk is a real course, very instructive and clear. Thanks a lot. Thank you.
You're very welcome. You probably have realized I've been working with this kind of technology for a while. I do some workshops, of course. That's also like part of like where I hope to educate developers, showing them how to do things better. And I usually just do or talk about things I have learned like throughout my careers. And if you're interested, I have another talk. You will find that from Devox, basically like on how to optimize your Spring Boot application, that it runs faster and so on. And this is just like what I've shown here. This is just like a small part of it. And there you would get some even more ideas.
Mm-hmm. There may be one final comment from Francois. I think what you mentioned before with the migration from Docker to Buildpacks, that Buildpacks will be much easier and quicker to use.
That's definitely because you just can run it from the command line. So basically it's like m4n spring minus boot colon build minus image, for example, and then you get it automatically. I'm kind of surprised that in Quarkus, when you create an application from scratch, you get like three default Docker files. There is an extension for Buildpacks, but it's really like a pity that it's not used more. And I think if people would use it more, there would be also more contribution. And of course, like it's maybe a little bit more difficult to like get around things like in the enterprise sometimes. But I have shown you, for example, how to add custom fonts. You can add like CA certificates via environment variables. You could actually like pass in some proxy parameters and stuff like that. So it's there. You just need to know how, right?
Mm-hmm.
Great.
So that I don't see any more questions right now, but I'm sure if people have more questions, then they can just contact you, or here are your coordinates. So maybe one last question. François mentioned many people also may know about the build native image command, but not that Paketo is behind it. It was
good point, actually. Yes, good point. So if you want to create a container with a native image, so just an executable with your application, if it's now Spring Boot or whatever, I mean, when you do that like with Maven or with Gradle, and I assume how François wrote it, he meant it with Gradle, they are using basically like a special way of building the application into a native image. And you don't need to have like RAL VM installed on your machine because it's part of the build image which is executed. So that means like within a container, your run container gets built basically, and in there is RAL VM, and will create the native image for you, right? Yes. Mm-hmm. So that's just the thing. So it's a very nice technology. Buildpacks, as you have seen very at the beginning, it's like a technology which is out there for many, many years. I remember the days of like Cloud Foundry where like the Buildpacks were part of the platform. So I just pushed the source code and the container was built there. And now, because of reasons and Kubernetes and so on, now we have to run it like outside of the platform. And that means like within our build pipeline or maybe on our local machines, which I find personally it's sad, because that means like I have to retrigger the pipelines more often to create new containers. Before it was way easier as an administrator of a cloud platform to just like change, for example, like the base image when we had vulnerabilities in the base image. But that's the way it is these days. Yes. Mm-hmm. But it's a stable technology, and even like the Java memory calculator is a very tiny, small Go application, and I never had issues with sizing my containers this way. So it's super cool and very stable. Yes.
Mm-hmm. So you see a future for Buildpacks in the future?
Well, they're there already. I don't think they're going away. Let's hope so. Mm-hmm. So it really depends also on the companies who are invested into this technology. But I like it a lot because it simplifies my life. And basically, like for all my pet projects I have, I just use Buildpacks for sure. And also like try to use it, if possible, like with my customers.
Mm-hmm. That's great. So thank you so much, Patrick, for the presentation
for hosting
and the talk. And I think thank you for the audience as well, for people who joined this session. And what I can tell, enjoy the conference, the other talks as well. So thank you so much.
Thank you. Bye-bye.
Thank you. Bye.